So section 10.4 talks about measures of central tendency. And so the first thing we have here is something called the mean or the average. And it says the mean or the average of a set of number items is the sum of the items divided by the number of items. Okay, so it says here, find the mean of the following test scores: 87, 75, 96, 91, and 78. Okay, so let's go ahead and do that. I'm going to grab my calculator here, guys, and I'm going to clear this out. So I'm just going to add my numbers: 87 plus 75 plus 96 plus 91 plus 78. Okay, and that's giving me 427, and we have 1, 2, 3, 4. We have 5 test scores, so we're going to divide it by 5, and I'm coming up with 85.4, right? Oops, that doesn't look like a pretty 5. So 85.4 is our average, okay? All right, let's take a look at the next problem. It says the mean score of a set of 16 tests is 81. Suppose 2 more students take the test and score 65 and 55. What is the new mean? Okay, so remember what we're doing here. When we're finding the mean, we took all the numbers that we had and we added them up, right? And so we had x1 and x2 all the way to x16, because there were 16 test scores, and we divided it by 16, and we came up with a number of 81. And now we're going to add 2 more test grades, and we want to figure out what's that average going to be. So if you were to think about this, remember the way we're getting the 81 is we took all our numbers, we added them up, and then we divided by 16 to get the 81. So let's do the step right before we divide by 16. So let's take 81. Okay, I'm going to take my calculator here. I'm going to say, what's 81 times 16? Okay. So that means that when we added up all of our test scores, we already had a total of 1296, okay? Now we're going to add 2 more, 65 and 55. And now we're going to divide these by 18, right? Because now we already had 16 tests. Now we have an additional 2. So that means that we have 18 grades. So plus 65 and plus 55 equals, and now I'm going to divide that by 18. And now my test average is going to be a 78.67. It'll probably tell you how you're going to round, okay? I'm going to 2 decimal places here. All right. So it says the median of a set of numbers in a numerical order is the middle number. If the number of items is odd, the median is the middle number. If the number of items is even, the median is the mean of the 2 middle numbers. Okay, so let's figure out what that means. Remember, think about median. You're driving down the road, they say you're crossing into the median. That means you're getting to the halfway point. So what we want to do is we want to put our numbers in order from smallest to biggest. So 36 is the smallest. Then it looks like we have a 65. And then we have a 71. 78, let's see, an 88, a 91, and 2 95s, right? 95, and let me scroll a little bit to my right. Oops, that's not what I wanted to do. Scroll to the right. There we go. And another 95, right? Okay, so now what I'm going to do, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I got 8 numbers here. So I'm looking for the number in the middle. The number in the middle, in this case, there is no middle number, so I'm going to take these 2 and find their average. Okay. So let me grab my calculator and let's say, what's 78 plus 88? And let's divide that by 2. I'm going to say it's going to give me 83. Yes, 83. Okay, so 83. So think about what 83 is. Half of the numbers are less than 83. And half of the numbers are greater than 83, okay? So 83 is the median. Notice 83 was not even a number that was in my set, but it's the median. It's telling me half of my numbers are smaller than 83 and half of my numbers are bigger than 83, okay? So it's that halfway point. Okay, so it says, suppose a class takes a test and the following averages are obtained. Okay, so it says the mean is 80, the median is 90, and the mode, which we talked about earlier, is 70. Okay, it says Tom, who scored an 80, would like to know if he did better than half the class. Remember what the median is. The median in this case is 90. Did he do better than half the class? I would say he didn't, right? So let's look at our options. Part A says the mean is 80, which indicates the balancing point for the data set is 80. The mode is 70, which means the most frequent score obtained by students is 70. Since most students scored below 80, which is the mean, and Tom scored 80, he did better than half the class. No, that's not true. The median is 90, which indicates that at least half the class had grades of 90 or more. Since Tom scored an 80, he did not do better than half the class. Yes, this would be my answer, right? Okay, so I'm not even going to worry about the other ones because remember, the median is what we're looking at here because he's concerned about half the class. Okay. All right. The mode of a set of numbers is the number that occurs the most often. It says it's possible for a set of numbers to have more than one mode or no mode at all. So find the mode of the following list of numbers. Okay, which is the number that occurs the most often? 15. 15 here is going to be our mode, right? Okay. All right. And it says the range is the difference between the largest and the smallest value in a data set. So if I were to kind of look here, say if I was looking at these numbers here. What's the largest value? 20. What's the smallest value? It looks like 10. So the range would be 10, right? Okay. All right. It says the youngest person in the company is 29 years old, and the range is 27 years. How old is the oldest company? So if I know that my youngest is 29, and the range is 27, and I want to find this number, we're just going to take 29 and we're going to add, what, 27 to it? 29 plus 27 gives me 56. 56. All right. So the next part we have here is something called quartiles. So it says quartiles approximately divide an ordered data set into 4 equal parts. The first quartile, Q1, is about 1/4 of the data fall on or below Q1. The second quartile, Q2, it says about 1/2 of the data fall on or below Q2. That's our median. The third quartile is about 3/4 of the data fall on or below Q3. It says, note, Q2 is simply the median of the data set, and Q1 is the median of the lower half of the data set. Q3 is the median of the upper half of the data set. Okay, so we're going to do this problem, guys. I'm actually going to do this on my iPad because I want to show you how to do this on an app that you can download for free. Oops. All right, so I'm going to do this problem here, guys, on my iPad because I want to show you that whether you have an Android phone or a iPhone or an iPad or something like that, you can use this app. Okay, so look what it's saying. It says the test scores of 23 students are listed. Find the first, second, and third quartiles of the data set. Okay, so what I'm going to do is I'm going to use this calculator app. It's right here in the middle of my screen. It says Graph and Calc 83. So I'm going to open this thing up. I'm going to clear everything out, okay? And the first thing I'm going to do, I'm going to go to my statistics button. It says stat. It's kind of right in the middle of my calculator. So let me hit that. And I'm going to go to edit, okay? So I'm going to click on this one. And if you see, I already have some numbers in here, and I want to get rid of those numbers. So I'm going to use my little up arrow button. And now I'm at the top, and I'm going to clear it out, okay? And I'm going to hit enter. Okay, so now my list is cleared. So what I want to do is I'm going to come back here and I'm just going to start listing these numbers. I'm going to start entering them in. So I have 31, 67, 67, 69. Okay, so I'm going to come back here and go 31, enter, 67, enter, 67, enter, 69. Oops, I made a mistake here, so delete it. There we go. There was another 67, and then a 69, enter, okay? And I'm coming to come back, let's see, we have 70, 70, 74, 75. So 70, enter, 70, enter, 74, enter, 75, enter, okay? Let me come back, 78, 79, 78, enter, 79, enter, okay. So it takes a little time consuming, 79, 80, 81, 83. 79, 80, 81, 83, okay. Let's see, what else do we have? 85, 85, 87. So 85, enter, 85, enter, 87, enter. Let me come back. Let's see, what else do we have? 90, 92, 95. So 90, 92, 95. And I think there's 3 more. 96, 97, 99. Okay, 96, enter, 97, enter, 99, enter. Okay, so now that I've done this, I'm going to hit my stat button one more time. And I'm going to hit the middle part here. It says CALC, like calculate. And I'm going to click the first one variable stats. And you notice it opens up my parentheses. And I want to put the numbers that I used from my first list. So the way I'm going to do that, if you look right above the number 1, do you see there's a little L1? So the way I get to that, I'm going to hit second and then L1. I'll close my parentheses and I'm going to hit enter. Okay. So a couple of things I can find out from here. This first number at the very top, it has an extra little bar. That's my average, 79.5, all that other business there, right? Okay. The other thing is, do you see on the second column it says min X, 31? That was my lowest score. And then if you notice, Q1 is 70, the median is 80, Q3 is 90, and my max was 99. So if I come back over here, it asked me to find Q1. Well, Q1, according to that, was 70. Q2 is the same thing as the median, which was 80, and Q3 was 90. So again, if you want to verify, they're right here in the second column, 70, 80, 90, right? If I wanted to find my range, remember, it's my biggest number minus my smallest. The biggest, according to my calculations here, 99 minus 31. So if I wanted to find the range, I could say, well, it's 99 minus 31, which would be 68, right? That would be my range. And if I wanted to find my mean, which is the average, I would just come back. And what was the average? The very top one on the top left, 79.52. So I might say 79.52. But I can find a lot of this stuff, guys, and I'm just using that little app. And it's going to be a lot easier, I think, if you use it than instead of trying to organize all the numbers together, okay? All right, so the next part here says, if you'd like to know the spread of the middle half of the data, then you're going to compute the interquartile range. So it says the interquartile range, I'm sorry, this is supposed to say range right here, guys. Sorry about that. IQR is a measurement of variation that gives the range of the middle portion of the data, about half. And so it says it's going to be Q3 minus Q1. So Q3 we found to be 90. Q1 we found to be 70, and that's going to give me a total of 20. Okay. So the next problem here says, in a Math 13-1 class, or 131 class at university, the grades on the first exam are shown in the table below. Compute parts A through G below here. Okay, and it looks like I forgot parts A. I have A, B, C, and D. But we'll figure it out, okay? Let's see. So first thing I'm going to do, I'm going to enter this into a table. So guys, I have a regular calculator here, and it works the same way it does on my app, okay? So I'm just going to go to the Stat button, and I'm going to edit. Okay, so I'm going to start entering my numbers in. So if you need to, remember, if you needed to clear it, you would just go up here to the top, hit the little up arrow, and then hit clear, and enter, and then it would clear everything out. So I'm going to start entering my numbers, 76, 79, 78, 93, 76, let's see, 79, 64, 78, 47, 61, 67, 51, 94, 66, 64, let me see, where was that, 68, 54, 70, 73, and 64. Okay, so now it's asking me to find a couple of things. It's asking me to find the mean, the median, the mode, the IQR. Okay, so let's see if we can do some of this. So I'm going to come back to stat, and I'm going to go to calculate, and I'm going to calculate my one variable stats, okay? And I'm going to hit second in my L1 so it knows which list I'm going to use, okay? So our mean, remember it's the X with a little bar on top of it, the very first number. So my mean here is 70.1, okay? My median, guys, is the same thing as my Q2, okay? So let me come back here, and if you don't see them, if you're using a calculator like this, you just hit the little down arrow. There it is. My median is the 69, okay? My IQ, I'll come back and do the mode in a minute. Remember, my IQR is going to be Q3 minus Q1. Okay. So let me see what's Q3, 78 minus 64. Okay, so let's do that here. So 78 minus 64 will be something like 14. Oh, come on. Go 14. Okay, the mode is the one that occurred the most often. Unfortunately, my calculator won't just tell me which is the mode, but I'm going to just kind of look here. And as I'm looking, what I'm seeing is my mode appears to be maybe 64. I see 3 of those. I'm trying to see if I see any other numbers that look like they repeat a whole lot. In the 70s, I do see a 79 a couple of times. So let me see. Here's a 79. Here's another 79. Now there's only 2 of them. 78, it looks like there were maybe 2 78s only. 76, maybe there was 1 and 2. Yeah, so it looks like 64 would be my mode, okay? And let me pause this real quick. All right, so let's see. The next part here says the interquartile range can be helpful in finding outliers. So it says using the interquartile range to identify outliers, we're going to find Q1 and Q3. We're going to find the interquartile range. We're going to multiply the IQR by 1.5. Okay, and we're going to subtract Q1 minus 1.5 times the interquartile range. It says any number less than this is an outlier. We're going to take Q3 and we're going to add 1.5 times IQR. And it says any data greater than this number is an outlier. So it says use the data in example 1. Example 1 was one of the test scores, okay, to find the interquartile range and identify any outliers. So if I scroll back up here, okay, so Q1, Q2, and Q3, right? So I know my IQR here is going to be Q3 minus Q1, which is 90 minus 70, which is going to give me 20, right? Okay, so if I scroll over here, we already know what our IQR is, right? Our IQR is 20. Okay, so we're going to take that number 20, and we're going to multiply it by 1.5. That's going to give me 30, okay? So now we're going to take Q1 minus 30, and then we're going to take Q3 plus 30. Okay, so Q1 was 70, minus 30 is 40. Q3 was 90, plus 30 would be 120. So any number smaller than 40 or any number bigger than 120 would be outliers. So if I come back up to the top, I scroll up here. Well, these were test scores, so we're not going to have anything higher than 100. So I don't have any outliers in the big on the larger scale, but I do have an outlier on the smaller scale. The 31 would be what we would call an outlier because it's going to be smaller than 40. So 31 would be my outlier. Okay. All right. So the other thing it says here, it says quartiles are often used in displaying data using a box and whisker plots, which use the five number data set, the minimum, Q1, Q2, Q3, and the maximum. Okay. So it says here, construct a draw a box and whisker plot, find the five number summary of the data set, construct a horizontal scale that spans the range of the data, plot the five numbers above the horizontal scale, draw a box above the horizontal scale from Q1 to Q3, draw a vertical line in the box at Q2, draw whiskers from the box to the minimum and maximum entries. Okay, so I'm going to draw my number line, and it's going to look something like this. Okay. So my minimum score we said was a 31, and I want to say the maximum was, I think it was actually a 99. Okay. Okay, so right in the middle, let me see, between 99 and 30. So right here would be about 65. Okay, so this would be, so if I go 30, say 40, 50, this would be 60, 70. You know what? Let's fix that. That doesn't look good already. Okay, sorry guys. Okay, let me draw this a little bit better. Okay. 99, 31, say 40, 50, 60, 70, 80. See, this would be 90, and I can just kind of extend this out and make this one 99, and kind of do that there. We'll flatten this out over here a little bit, okay? All right. Okay, so my Q1 is going to have a box. It's going to be a line going down like that. We're going to have another line like this, another line like this, one like this, one over here. I'll put dots here, and dots here. And actually, I'll do them in red so they're a little bit more visible. Okay, because I want to show you what it is I'm doing. Okay, so look, here's my minimum entry right there. My Q1 is the first number. My Q2 is the second. My Q3 is the third. And that is the last one right there. Okay, so I got all my numbers down. Okay. All right. So when we have these sort of box and whisker plots, and before I go on, guys, what we normally say is about 25% of the numbers are here. There's another 25% of the numbers here. There's another 25% of the numbers here. And there's another 25% of the numbers here. And you might say, well, look, this doesn't look like it's even. Well, it's not necessarily supposed to be even. But what they're saying is that about 1/4 of the numbers are going to be between 31 and 70. So if I came back over here, right, to my original problem that we had right here, and we said about 1/4 of the numbers are going to be about, between 31 and 70. So look how many numbers I have here, right? 1, 2, 3, 4, 5, 6, right? Okay, so if I were to take 23 and divide it by 4, that would be 5.75, almost 6 numbers, right? So again, that's why they're saying there's so many numbers right there. And then there should be roughly 6 numbers in between each of those ranges, right? And then I could do the same thing. Let me get my pen going again. Sorry, it's kind of freezing up on me. Here we go. 1, 2, 3, 4, 5, 6. Again, that are falling in the next category, right, which I want to say went up to 80. If I come back here, so there's another 25% of the numbers that are kind of following here, following here, following here, right? Okay, so just kind of giving you an idea. So it says to the right are box plots comparing the ticket prices of two performing arts theaters. What is the median price for each ticket? For each theater, I'm sorry. Okay, so the median, guys, is going to be the number in the middle. So for B, it's going to be 50. Okay. For theater A, I'm going to just scroll down. It's going to be, what, 62? Okay. Now, it's going to say which theater has the greatest range of prices. What they mean by that is which one is the widest. Well, it looks like A is, right? Because look, this is 80 and this is 44, right? So if I were to say what's the range of A, be 80 minus 44, which would be 36. If I were to do B, it's going to be 62, that's the biggest, minus 38. So 62 minus 38 would be something about 24. So yeah, A is going to have the widest at 36. Okay. What is the highest ticket price at either theater? Okay. So for A, it's going to be 80. And for B, it looks like it's going to be 62. Okay. And then it says, make some statements comparing the prices, the ticket prices at the two theaters. Okay, so, a couple of things that we can say is the median price for A is the same as the maximum price for B, right? Because those are right there. We might say something like Q1 for A is going to be equal to Q3 for B, right? So here's my Q1 for A. That's the same as my Q3 for B. And then maybe there's another one I can probably compare right here, right? So my minimum at A would be the same thing as my Q1 at B. Those are just a couple of comparisons that I might make there, right? Okay. All right, here's another one. He says, what are the minimum and maximum values, the median and the lower and upper quartiles of the data set who's shown here? Okay, so let's see if we can find this. So let's go minimum. Minimum is going to be 0. And I'm just going to go in order, guys. Q1 is 10. Q2, or my median, right, same thing as the median, is 20. Q3 looks like it's going to be, what, 35? And my maximum looks like it would be 70. Okay. Okay, so there's something called standard deviation. Now, we're not actually going to figure out how to calculate it, but we're going to figure out what does it mean. Okay. So when we have a set of numbers and we find something called the average, right? The average is going to be right here in the middle, okay? And then we're going to find something called the standard deviation, okay? Standard deviation, a lot of times we call it the spread, okay? And so there's something called the empirical rule, or they call it the 68, 95, 99.7 rule, or sometimes they use 99.8. But it says for data with a symmetric Bell distribution, the standard deviation has the following characteristics. It says about 68% of the data lie within one standard deviation of the mean. Okay. About 95% of the data lie within two standard deviations of the mean, and about 99.7% of the data lie within three standard deviations of the mean. So here's my spread, right? And one standard deviation, one less and one bigger, we would have 68%. Two less or two smaller, we would have the 95%. And three less or three smaller, we would have the 99.7%. They're all going to lie within there, okay? So I'm going to show you how we can use that information to figure this thing out here. So it says fuel economy estimates for automobiles built in a certain period predicted a mean of 27.2 and a standard deviation of 4.8 for highway driving. Assume a normal distribution can be applied. Within what range are 95% of the automobiles? Okay, so I'm going to take 27.2, right? 95%. So if I come back here, it tells 95% are within 2 standard deviations of the mean. Okay, my standard deviation, guys, was 4.8. So what I'm going to do is I'm going to take 27.2 and I'm going to subtract 4.8 twice from it, okay? Because I'm going to go 2 to the left and then I'm going to do the same thing but 2 to the right, okay? So what I mean by that is I'm going to take my calculator and I'm going to say, what's 27, oops, turn it on first. What's 27.2 minus 4.8 minus another 4.8 because I got to do it twice. And that's going to give me 17.6. Okay. And I'm going to take 27.2 and I'm going to add 4.8 to it twice. I got to do it twice because it says it's within 2 standard deviations. So 27.2 plus 4.8 plus another 4.8, that gives me 36.8. Okay, so it says what range are 95% of the automobiles? Between 17.6 and 36.8 miles per gallon. Okay, all right. And it says the next problem here, it says for certain workers, the mean wage is $5 an hour. That's horrible. With a standard deviation of 50 cents. If a worker is chosen at random, what's the probability that the worker's wage is between $3.50 and $6.50? Okay, so we're going to take $5, right? That's our, and we're going to start subtracting, we're going to start subtracting 50 cents until I get to that number there. Okay, so we're going to say $5 minus 0.50. That's once. Nope. That's twice. Nope. That's 3 times. Yes. Okay. So 3 times. So I've done a standard deviation. I had to do it 3 times to end up with 350. Okay. And if I did that same thing and I added 50, keep doing 0.05, not 0.5. And I added 50 cents, if I were to do that 3 times, guys, I should end up with 650. So look, 5 plus 0.50, that's once, that's twice, that's 3 times, there's our 650, right? Okay. Okay, so we did this 3 times, right? So if I come back up here and I look at this piece right here that says about 99.7 of the data lie within 3 deviations of mean, I had to do that 3 times. So what percent would I have? 99.7%. Sometimes, guys, they use 99.8. So just to give you a heads up. Okay. All right, so it looks like we got one more problem here, and it says the mean IQ score for 1,600 students is 105 with a standard deviation of 5. Assuming the scores have a normal curve, how many have an IQ score between 100 and 110? Okay, so we're going to start off, remember my mean here, my average, X bar for my average is 105, and my standard deviation is 5. So if I subtract it once, 105 minus 5, that gives me 100. If I go 105 plus 5, that gives me 110. So that's 1 standard deviation, right? And according to the empirical score, I'm going to come back up here. Look at this chart here. So let me erase some of this mess here. And let me circle this. 68% of the data, okay? So for part A, I'm going to say 68% of how many students am I looking at? 1,600. So I'll take my calculator, move it over here, 0.68 times 1600 is giving me 1088. So for part A, I'm going to have 1088. Okay. Part B, it says between 95 and 115. Okay. So look, remember, if I had my average being 105 and my standard deviation was 5, and we said 105 minus 5 is 100, and if I subtract 5 again, here's my 95, and I have 105 plus 5, that's 110, and if I add another 5, that's 115. So we had to do this twice. So twice, if I come back up to the top, and I look at this, within 2 standard deviations, 95%, right? So now I'm going to say, well, 95% of 1600, right? So I'll take 1600 times 0.95 is 1520. Okay, right there. And then there is a part C. And it says, how many have an IQ score over 120? Okay, so let's think about it this way. My X bar was 105, my standard deviation was 5. So we know that when we added 5 once, we came up with 110. When we added 5 twice, we ended up with 115. And if we do it a third time, we're going to get 120, right? So I'm going to come back up here, right? So I'm already here is my third one, right? This would be 120 right here. We want to know how many have more than that, okay? So think about it this way, guys. What we're looking at when we're talking about the percentages, we're talking about the area underneath this curve. So the area has to add up to 100%, right? So if I already have 99.7 after I do 3 deviations, I want to figure out how much is left here and how much is left here. So if I do 100 minus 99.7, let me do that. That's going to give me 0.30. And then how much would be left here? Divide that by 2. I would be left with 0.15. Okay, that's a percent though. So I'm going to say 0.15% of 1600, which is 0.0015 times 1600. Okay. So let me move this over. 0.0015 times 1600. And 2.4, so I'd say about 2 students are going to have a score over 120. Okay, and that there right there, guys, is all of 10.4.